So hello guys, we are going to discuss question number 575. The question is asking to distribute candies. So basically in this question what we have Alice and she is having n candies. N here represents the size of array. For example, the size of array in this is 6, one term is missing. And what she is having, like she is gaining weight. So we have the doctor advised that you can only eat n by 2 of the candies. And what we have to do, like we have to maximize the different type of candy, and the doctor is recommending n by 2 amount of candies, and where n will be always even, so n by 2 term will also be even as always. So what we have to do, we have to just maximize the different type of the candies. For example, in this array, let me rub this, we have this simple array. These are the different type of the candies, like this is the type 1, this is type 2 candy, this is type 3 candies. Okay, what we do, the doctor is advising at most you can eat n by 2. The size is 6, so n by 2 will be 3, so she can eat at most 3 candies. She wants to eat 3 different type of candies. We have to return if she can eat 3 different type of candies, or 1 different type, or 2 different type. So for in this array there are these different types 1, 2, 3, and so she can easily eat 3 different type of candies. So also let me give you different example, like this is your array. So like this is any type of candy, and the doctor is advising him to eat n by 2, which will be 4 by 2, which will be equals to 2. So she can eat at most 2 types of candy. Now we have to return, is it possible that she can eat 2 types of candies? So we have to see how many different type of candies she is having. So as you can see, this is the array, and the only possible type in this array is this. So she can only eat 1 type of candy, and she can eat 1 candy only. So we have to return this. And if I give you another example, like this will be your array, size is 6, so at most she can eat 3 different type of candies. But if we look, the only type possible are 1, 2, and okay, so let me write 3 and add 2. So the only type possible are 1 and 2. So she can eat only 2 types of candy, so return 2. So what we are looking in the pattern of this question is, we are given some type, then we have to return the different type, or the difference of the candy. So if we look closely, what basically we have to do, we have to find the number of unique candies. Like this was a question, let's write it again, 1, 1, 2, 2, 3, 3. N is equals to 3. We have to return if we have to check if she can eat 3 type of candy. If not, how many possible different type of candy she can eat. So to keep track of distinct candies, what you can do? Then simply use a set. You'll traverse through array. You'll keep track. This will be your set. Then you will check if size of your set, okay, side of the set is double equals to n by 2. If it is true, set dot size is double equals to n by 2, n is your size of array, is double equals to n by 2, then you return n by 2. It means, like if your set is having these 3 elements, size of the set will be 3, and she can eat at most 3 candies. So both are equal, then she can eat 3 candies. Otherwise or else, we can write return size of set. Okay, for example, this was a candy, let me write this 2, 2. So the only possible type she can have is 1, as you can see, and the 2 type, second type of the candy. So if you see, n is equals to 3, because size of array is 6. 3 won't be equal to 2, so we will return 2. She can eat only 2 types of candies. This will be your solution, where time complexity will be big O of n because you are traversing through the whole array, and then space complexity, time complexity will big O of n as you are traversing, and the space complexity will be big O of at most n because there can be at most n different candies. It will be somewhere around 1 to n, the different type of candy sources. So size of the array or the size of the set you will use will be 1 to n. Okay, so the second solution that you can think, instead of just instead of just having big O of n space complexity, you can reduce it to big O of 1. Okay, now let me tell you how to do that. Sorry, a big O of n, say we are going to big O of 1 space complexity. So if you look closely, let me write it better way. This was the original question. So she can eat 3 types. So what you can see, you checked if she can eat this candy, then you'll move to the next candy. If you compare it with the previous candy, if there is any difference, or if these two values are not equal, what does it mean? That we have different type of candies. Okay, then what we'll do, we'll increase the different type of candy, and at last we'll return the different type of candy or that count. So let me give you a dry run for that. Like if initialize your count variable with 0, your I pointer will be here first. Oh sorry, not there, because it will be here out of bound. It will be in the first position. You check with the previous. I will be here, you check with the previous. If these values are different, then count will increase, otherwise not. First count is 0. Okay, let me write it properly. Count is 0. There is no different type of candy, so we won't increase. We will move to the next one. Then we will check if these two has different value. Sorry, count will be 1 initially because this was a type. So we will check these two are different values. Yes, these two are different values, so we will increase to 2. Then we will move here. Then we will check if these two I and I minus 1 is different or not. If it is different, then we will increase the count. It is not different, so we won't increase the count, it will be 2 only. Then we will move it to the next position. We will check if these two values are different. If these two are different, then we will increase the count. So at last we will return the count variable, which will be 3. So let me give you dry run of another example, so that will be most good, or that will be more understandable for you, easy to grab. This was the question. N will be here 3. We will check. Count will be initialized to 1 because the I will be always having a type of candy or a one unique type of candy. I will be here. Sorry, I will be here. We'll check if it is different with previous value or not. Then we'll check, no, it's not different, we won't increase the count. So we'll move our I pointer to here. We will check if these two are different. So yes, it's different. So we'll increase the count. Then similarly we'll move I, we'll compare it to this one. So no, these two are not different. Then we'll move I here, then we'll compare it to previous one. No, they are not different. I will move here, then we'll compare with this one. No, these are not different. So we'll return, we can only have 2 type of candy, or Alice can only have 2 types of candy. So I hope you understand the solution. There was nothing in the code. You just need to simply sort the array. Okay. Then you will initialize count equals to 1. Okay. And for loop, you create I from 1 to, as I told, 1 to n. Okay. And what we will do, we will check if array of I minus 1 is not equals to array of I is not equals to array of I, then we increase count. And one thing also, there can be one more case if she is having lot of different types. For example, this is a type 3, 4, 5. So she can eat 3 types. Then we will return only 3. We won't return, like, can't return this. we won't be returning this 5, we'll only return 3. So we'll check if your count is equals to n by 2, then you'll return count. Okay, so we'll keep that in mind. At last you'll return count. Okay, you can also return count here. So this will be the basic code. It's very simple. It was kind of confusing, but this is the best, or this can be a very intuitive and the best solution you can get. Thanks for the watching the video. Like and subscribe to my channel. Bye bye.
You gon' see success in me. You ain't seen the rest. I just wanna be the best at what